Welcome to a new episode of the MBSE podcast. Today, in our 62nd episode, and we rather thought about how old is this podcast, and we are in the 6th year, yeah? More or less 12 episodes a year, and we are in the 62nd. Yeah, this time we have two guests, not two Germans this time. Two other Europeans, and with me as a half Italian, we have the majority now, the Italian majority in this podcast this time. Yeah, we very warmly welcome Luca and Francesco. They are both from a research project called ODE4HERA, but we will talk about that in the next minutes. First of all, Luca, please introduce yourself, and afterwards, of course, Francesco.
Hi all. Hi Christian. Hi Tim. Thanks for the invite, first of all. Glad to be here. My name is Luca Boggero. Indeed, I'm Italian. I'm working at the German Aerospace Center DLR, Institute of System Architectures in Aeronautics in Hamburg, since 2018, so already for 7 years. And here I'm leading one of the research groups. It is named Digital Development Process. And before joining Germany and DLR, I completed my studies in aerospace engineering at the Politecnico di Torino, so Technical University of Turin, where also I did my PhD. And this was also the first time that I, let's say, entered into contact with MBSE. And
yeah, Francesco.
Yeah, hello everyone. Hello team, hello Christian. Yeah, again, thanks for inviting. Glad to be here. So I'm Francesco Torrigiani, also from DLR, the German Aerospace Center. I'm a research engineer in the same group led by Luca in Hamburg. I have a background more on MDO stuff and elasticity, so I started to get in touch with MBSE topic a little bit more recently, and and my focus is really on linking these two domains. I'm here also as, let's say, representing the project in the role of the coordinator of the project, so ODE4HERA, that we will hear a little bit more about in the following of this episode.
Okay, great. Yeah, fantastic to have you both with us in this episode about ODE4HERA. Interesting project. But before we start about that, well, you're both member of the Digital Development Process Group. It's a research group. So what does your research group do?
Yeah, so in our group, we want to develop or investigate processes, methods, and tools that would improve and accelerate the development of aircraft or other aeronautical systems. So our institute is pretty aeronautical. For that, we are leveraging not only MBSE, but also other approaches like MDO, which stands for Multidisciplinary Design and Optimization, but also trade space exploration. So we do our research thanks to projects, research projects in which we are involved or which are coordinating. National project, but also international project. And of course, ODE4HERA is one of those projects.
Cool. So let's talk about more or deeper into this ODE4HERA. So what does it stand for? What is it about? And yeah, I already know some things of that, but yeah.
Yeah. So ODE4HERA stands for Open Digital Environment for Hybrid Electric Regional Architecture. It's a European project funded by Clean Aviation Program. Just quickly about Clean Aviation is a joint undertaking, meaning there is European and also public and private entities in the aeronautical sector that are funding the program itself. And the primary goal of the project is to accelerate the development of this hybrid electric regional aircraft configuration. So maybe the first question is, why hybrid electric regional aircraft? Yeah, the reason is that they present and they imply a far higher complexity than conventional turboprop aircraft configuration. So it's a great application case to test this digitalization development, which is really the focus of the project. And actually, these digitalization challenges, due to the complexity of the configuration, it's what put at risk the achievement now of the entry into service for this kind of configurations. And how we can accelerate the development of this kind of aircraft. From our side, we propose this digital platform to collaboratively design both the aircraft as a whole and also the subsystems. The same way, the ODE4HERA project is a collaborative endeavor. So it's a European consortium. We have organizations that are actively developing this digital environment, and mainly is DLR, so the German Aerospace Space Center. There are different entities of Siemens. Then there is IoT, which is also a research center in Toulouse, and Gensoft, which is an SME from Italy. Then there is a group of partners that develop the different digital models: Aeromax, Skylife, University of Naples, University Carlos III of Madrid, and INTA, which is the aerospace research center of Spain. And then there are also the final user, which are Leonardo and Airbus Defence and Space, which are actually the one leading two test cases, because what we develop, we want also to test that, and we have two specific hybrid electric configuration that we want to design in order to test our development. Then finally, there is a Esploro, which is taking care of the dissemination and communication activities, which is very important for a European funded project.
Okay, so if I got it right, you build the platform, no, that can an engineering platform that can be used to build HERS, and HERA is this hybrid electric regional aircraft, right? So yeah, what is a hybrid electrical regional aircraft? We look all for clean mobility. So is this then an aircraft for passengers and it's purely electrical? And so what is it?
So maybe we can start saying that the aircraft was not, or this concept of aircraft was not, let's say, suggested by us of the consortium, but it's proposed by the Clean Aviation Framework that Francesco before mentioned. It's a regional aircraft, so it is used for mainly domestic flights, carrying around 50 to 100 passengers. It's not the single aircraft, let's say, investigated by Clean Aviation. There's another one which is a little bit larger. It's a short, medium-range aircraft bringing more passengers, 200 and 250 passengers, for flights within Europe, so maybe from Hamburg to Rome. So Clean Aviation does research for investigating new technologies towards a sustainable and climate neutral future. So this is also what is being investigated with this hybrid electric regional aircraft. It is also important to say that this kind of aircraft don't have the or don't produce the highest amount of emissions in the aeronautical sector, but they can be considered as a ready solution, entry-level solution before transferring these technologies to larger aircraft and therefore to the entire aviation sector. So yeah, these aircraft have new systems, new technologies. They leverage electricity, for example, to reduce the environmental impact. The problem is that these new technologies, new concepts, they can have an impact on the development process itself. The development process can become more complex. It might require more time. It can also be more prone to error, so it's also prone to risk. So that's why in the project we want to improve this development process, and we want to do that by leveraging on digitalization, like a model-based approach. And this is why in the ODE4HERA project, we want to develop this open digital platform that Francesco previously mentioned.
Can you give us some more insights to this open digital platform? Because platform could be anything and nothing. And very often people announce platforms and you never know what it is. So now we have the experts here. Give us, please, a little bit more insight.
Yeah, correct. Platform, there are already a lot of platform, a lot of digital platform. Why do we need a new one? So maybe the first thing I need to say, it is not exactly a new one, meaning that is actually a constellation of legacy tools that are already out there, which they do already a great job at maybe some specific task or a group of tasks in the development process. But the focus of our work, of our development in the project is really how to connect together this heterogeneous constellation of tools. So we do not really focus on the development of the single tools for a specific task, how to link what is already out there to ensure consistency and traceability of these exchanged data. And then it's already in the name that we use for this platform, open digital platform. Openness is really a key aspect of what we do. Open doesn't mean that all this constellation of tool, all of these tools are open source or open accessible. It's actually very heterogeneous, as I said. There are commercial tools, there are research tools, there are open source tools. But the open here means that we do not want to force the user of the platform to choose a certain set of software solutions, or a software environment, a vendor specific software environment. So the user is free to choose the software or the tool that is more, let's say, familiar with, and that he thinks or she thinks that is the most suitable for that task at hand. So these are really the key aspects of the platform.
But I assume that there are limits, so I cannot randomly exchange the engineering tools. Otherwise, you would have a platform where I can exchange all engineering tools and then they work together. Then you are rich. And so I can exchange some of the engineering tools. So maybe you have embedded SysML modeling tools, so then I can use different of those modeling tools. Is that correct?
Correct. So. But that doesn't mean that what we provide is omnicomprehensive. So in the consortium, we have available a set of tools. I think, as I said, it's quite representative of what is out there, given the consortium that we have. And it doesn't mean that when the project is over, it's done. You can collect everything. There is still the need for the tool developer to develop the interface with this platform. So this is something that we are doing in the project. For the tools that we have available in the consortium, we are developing this interface. But the main point here is that we have a streamlined, let's say, process to integrate these tools. And more importantly is that we are working on the common and shared meta model for the data to really enable this consistent and traceable exchange of data throughout the process. So what we call the ontology. And and this is really.
Can I compare it to OpenMBE? So the same pattern where I have to develop an MDK, so an interface adapter, and then I can connect to the OpenMBE ecosystem with any tool. But I have to develop this adapter, and that's
exactly, yeah. The development of the adapter. We actually use the same term, the adapter. This is, let's say, something that the tool owner need to develop if you want to be connected to this environment.
Okay. I have one more question about the openness. Does openness also means that I can develop other systems than HERA systems with that? So, or is it really focused on hybrid electric regional aircraft?
Yeah. So this is a very interesting question indeed. So what I said is really that openness is a key aspect, and consistency and traceability of the exchange data enabled by this common meta model that we have. And then the other, let's say, third aspect that we really take care about is the task automatization. So we have some automatization, let's say, capabilities that really focus on what is needed for the hybrid electric regional aircraft development. So this kind of automatization, some of them are quite generic. For example, I don't know, automatic setup of the MDO workflow. This is in theory not specific to the system of interest that you are optimizing, or for example, automatic generation of the simulation, the dynamic simulation models that you want to run for virtual verification. This is not common, but these are, let's say, there are key aspects of this complex product that and key task of for the design of this product that we want to automatize. So let's say we have that in mind when, especially when we look at the automatization of the task, and then also the test that we do on the platform itself. So the actual test case, it's a hybrid electric regional aircraft test case. So there is a lot of things that can be reused, of course, but some aspects, let's say, are specific for this, at least for the aeronautical world.
I think also some of these tools of the ODP are also used generally for also other configurations, not exclusively for hybrid electric regional aircraft. Of course, as Francesco said, when you move to the design simulation part, the MDO part, and there you have disciplinary models exclusively addressing the hybrid electric aircraft. In that case, we are constraining to this specific application.
Okay.
Okay.
And
but
you
maybe
yes.
one other thing, the two that we have there are tools like Siemens SimCenter, Siemens AMESIM, or we have our tool that we use not only for hybrid electric regional configuration. We have GemCell, which is an open source tool for MDO. So these tools are not really specific for hybrid electric regional aircraft at all.
But you already mentioned in a sentence the ODE4HERA ontology, which I guess brings also some order in the chaos, right?
Yes, indeed. So we call it ontology. It is in practice a data meta model that enable this consistent and traceable exchange of data between these different tools. Sort of a common language used by these different, let's say, modules of the to exchange information. There are different aspects or different, let's say, advantages in agreeing on this common language. For example, you can drastically reduce the number of interfaces that you need to develop to connect this network of tools, because everyone just needs to develop an interface to this common exchange data model, and not the specific tool interfaces. That of course brings also benefit in terms of maintenance of the of such an environment. And what we also think is very important, and it's also why we call it ontology, is because it's a little bit more than just a data format, but it brings some semantic with it. Each element of this meta model actually has some abstract concept behind it, and which, let's say, should facilitate this interface development with new tool that you want to integrate in the platform, and also, let's say, give us a good guidance when we want to really streamline the process and do some automatization, and really can focus on this high level task of the development process without going into the raw data handling. and that then in practical terms is a SysML v2 extension library. So this is what it is at the end.
Okay. So, and why do you choose SysML v2 for an ontology?
Yeah, indeed, is a good question. We spent some time at the beginning of the project to really try to make the good decision about that. So the project is also a 3-year, that I didn't say at the beginning, is a 3-year-long project that started 2 years ago. So we are at the end of the second project. So it was actually, let's say, really a good moment for SysML v2, because it was really, I mean, SysML officially, SysML v2 specification was not out there, but let's say the community was starting to really be loud about it. So we, part of the reason is that we also got excited about that. But then we also see the potentiality. For a lot of time, we actually thought about RDF as the format for or the base, let's say, for this meta model, and there are also different options. I don't know, the relational database, for example, but there are, let's say, advantages and drawbacks for these different options. But what is really what let's say made us decided why we decided for SysML v2 was that is, let's say, as the second version of SysML v1, which is already the de facto standard for model-based system engineering. What is really attractive for us is this text annotation. So this machine readable capabilities, and that was, as you hear before, was really a key aspect for us. And then differently, for example, from RDF, you already have kind of a good base layer of semantic, of abstract concept that you can readily use. For sure, you can do everything that we do with SysML v2, you can do also with RDF, but you have to look at you have to put a lot of effort at the beginning to really define a good, let's say, a good vocabulary, a good initial ontology on top of which you can build, let's say, your actual what you need for this kind of task automatization. Instead, SysML v2 allowed us to really start immediately to discuss the more detailed, let's say, higher level elements, abstract elements.
And I was luckily invited to your last workshop in Hamburg, and it was really interesting to see how smooth the interconnection with the text annotation worked. So it were really totally different tools, not SysML v2 tools, but they spoke SysML v2 and they could work together, and that was really amazing to see.
Yeah, thanks, Christian. Yeah, smoothly. Let's say it's a research project, of course. So it's really a research. So there's a lot to be improved. But yeah, we had at the middle of the second year, of course, we had started to have some results, and it was also interesting because it is really a very heterogeneous set of tools. So that was really a challenge.
Okay, so let's go a little bit more in what you are doing as DLR. So what exactly is the role of DLR, except of managing the project together with Esploro? Why exactly your group, Luca? And what's on the other side the benefit for the aeronautical scientific community from these kind of projects?
So ODE4HERA is the last project in this context that our group is coordinating. We started already 10 years ago, exactly, with another European project. It was called Agile, where the focus was not on the MBSE, but on the MDO part, so multidisciplinary design optimization. the aim there was to support the formulation, execution of MDO workflows involving different disciplinary experts. Then at the end of this project, Agile, we started another project, again coordinated by us, which was called Agile 4.0. We shift there the focus from only MDO to model-based systems engineering and MDO. The two domains were linked. And we didn't focus there on the, let's say, on the research tools, so we developed some research tools, but we didn't focus too much on the connections between all these different MBSE and MDO tools. And then afterwards, we started ODE4HERA, so we can continue also what initiated in Agile and Agile 4.0. So other than coordinating the project, we also bring our experience and expertise with common exchange data format. At DLR, we have invented a format which is called CPAX, which supports the connection of the different or exchange of variables during the MDO loops. And also in ODE4HERA, we provide several tools supporting requirements management, system architecting, MDO formulation, and we support partners like Airbus Defence and Space and Leonardo in using these tools with the two application cases, let's say, addressing the project. And all these tools that we bring are also part of the Open Digital platform.
Okay. So you mentioned Agile. That's was it about Agile development, or is this an abbreviation for something else?
No, nothing to do with the Agile development. It is actually an abbreviation. I think that A stands for aircraft, I think, but I don't remember.
Okay.
I don't remember. But yeah,
Yeah,
it was
what
an
was
abbreviation.
next generation MDO was very, very complex acronym, and then yeah.
But Agile sounded good, and yeah, that's very often with these acronyms.
I saw it several times on LinkedIn during that time. I remember that. It's like, Agile? Is this Agile systems engineering as well?
Yeah, we got that question at every conference. Let's say,
Yeah,
like
I
in the
assume
coffee
that.
break. Do we do Agile development?
Right.
Not really.
Yeah, you mentioned a lot the two project partners, Airbus Defence and Space and Leonardo, but the ODE4HERA project, the objective is to finally develop an hybrid electrical aircraft for, it's a commercial aircraft, right? But both organizations do not build commercial aircrafts. Is that correct?
Yeah, so Leonardo also develops also regional aircraft, especially in the south part of Italy. It was also in, I think, several years ago in joint venture with, I think it was at HERA and Airbus, and so basically they also develop, let's say, regional aircraft. And Airbus Defence and Space, they can also bring experience and expertise that they would use also in different domains, let's say not the civilian one. But anyway, they have knowledge, experience with aircraft design. So it's very good to have them on board for validating the developments of the project.
Okay.
Yeah, and it actually both, they were really interested about the technical development. So the main outcome of the project is not really the aircraft configuration. So we will not going to deliver, let's say, the best hybrid electric regional aircraft configuration. For us, the outcome, the result of the project is this digital platform. So they were both, let's say, at least the department of Leonardo and Airbus Defence and Space that are involved in the project are really interested in this outcome. And then, as I said, Aviate electric regional aircraft are a very good test case, given the system complexities.
Okay. So this is a public funded project, so of course also the public might gain some advantages from it. So where can I find something about it?
So we, of course, we are doing some publication. There was, let's say, recently some the ESN conference where we had a full section dedicated to the project, and then we have some other publications, some other conference or journal papers, so they can be, let's say, tracked also through our website. So ODE4HERA.eu. If there is a description or something in the podcast, probably we can drop it there.
Yeah.
And then what I mentioned before is the ontology. So it's really something that is very important to make it publicly accessible. So we are gonna publish it first version in Zenodo by the end of the year. And again, it will be also, let's say, we will give the news also in our dissemination channel, LinkedIn, website, etc. And also, I mean, now I'm introducing a new topic. Well, let's say SysML, which is this distribution mechanism for SysML v2 libraries. We are going also to publish the ontology there on SysML. But yeah, now if we want to talk about SysML, it's another podcast episode, I guess.
Right.
Literally.
Yes. And Zenodo, what is Zenodo? I've heard of it before, but I don't remember exactly what it is.
Yeah, Zenodo, Luca, complete if I miss some information, but like it's it's a platform, is a distribution platform for any kind of artifacts, not only let's say papers, presentation, or let's say text or document, but also let's say any kind of models. You can drop it there. You get a DOE, I think, so an identifier, and then you can refer to it. And then you have a community, and then we have an ODE4HERA community where we published our, let's say, our results, and the ontology is going to be there by the end of the year. It's a first version, of course. It's going to be to change by the end of the project, but we will publish it by quite shortly. I mean.
Okay. Cool.
And you said the project will end this year or next year, so you're almost at the end of this next year. And is there already a plan what comes next?
Yeah, exactly. Well, what comes next? So we need to enlarge the set of tools that we have integrated in the platform, because still we have some of them not integrated that are already in the consortium, and then the ontology as well need to be enlarged a little bit. There are some domains that we didn't touch at all, or very little, and we want to cover some other parts and then further testing it.
Then we want also to continue with the dissemination. We already have organized open day workshop in September, and we were glad also to have you there, Christian. But we plan to organize another final one in around the end of the project. So open to, I mean, everybody who wants to attend, so we can disseminate all the achievements and the results of the project. And again, also for this event will be more news in all our channels of the website, LinkedIn, so people can be informed and can hopefully can attend.
Cool.
And I assume it will be again in this wonderful Saal.
Yes, it will be here in Hamburg.
Nice.
Yeah.
Yeah, very good. Wow, interesting project, and very important stuff. And with SysML v2. Yeah, with that, we come to the end of this episode, I think. So, yeah, thank you very much, Luca and Francesco. for being here.
Thank you. Thank you.
And providing insights into this project. And well, you already mentioned CSENT. And yes, really a good topic for another episode, and it will be our next episode. The next episode will be about CSENT. It's this year, so the last episode in this year, December 15th. We will have the episode a little bit earlier. I think it's 1.5 hour earlier, but you will see the announcement on the internet, LinkedIn. And users from Sensemetry will be with us, maybe also another guest. Yeah, and then, well, I think, well, you should not forget.
Trust us, we are systems engineers. Goodbye.
Bye-bye.
Bye.
Bye.